working on this number 1 problem. What relationship do these two angles have together? They're alternate exterior, so go ahead and write that in. They're alternate exterior, so what does that tell me about them? They're congruent. So if they're congruent, what am I going to do with their measures? I'm going to set them equal. So 2 times x plus 10 equals, what is it? 3 times x minus 8. All right, so then what's my first step? Distribute. So 2 times x is 2x. 2 times 10, 20. 3 times x, 3x. 3 times negative 8, negative 24. All right, so I want to move my smaller x, which here would be 2x. So how do I move 2x to the other side? Subtract it. So that means I have x that remains on the right. How do I move this minus 24?
Add it to 20.
Add it, yep, to both sides. I did it in one line because I don't have room. But what's 20 plus 22? Or sorry, 20 plus 24 is 44. So it says solve for x. We did that. Then it says explain your reasoning. So why did we set them equal? Because they're congruent. Why did we know they were congruent? So your explanation you wrote down at the beginning. So they're alternate exterior, therefore they're congruent. So that would be your reasoning. I would circle it. I finished grading your test, and the number 1 reason people got a lot of points off is because they did not explain their reasoning. You can't ignore that part of the question because the point of geometry is to have reasoning. Okay, so make sure you do that. The second problem, what relationship is there between these two angles? They're consecutive interior. And then what do we know about consecutive interior angles? They're supplementary. All right, so consecutive interior, that means they're supplementary. So that's my reasoning for what I'm about to do. So if they're supplementary, what do I do with these two angles?
You add them together to make 180.
Add them together, and then they equal 180. So plus 120. So you have two angles. You have 4x minus 12, and then you have 120. So we're adding both angles, and they equal 180. You're not working on homework in my class. That is disrespectful. Go ahead and do what we're doing. 4x minus 12 plus 120. So minus 12 plus 120 is? What is it? Guys, what's 120 minus 12? 108. And it equals 180. So my next step, subtract 108. So 4x equals 72. Divide by 4, and x equals? How many times does 4 go into 7? Once, with 3 left over. How many times does 4 go into 32? 8 times. So it's 18. All right, and again, our reasoning is that they're consecutive interior, which means they are supplementary. You're going to go ahead and take out your homework. If you're using a late pass, get your textbook and a sheet of paper. You've got this. It's a weird word. What's that weird?
Consecutive interior.
Yep, and what do consecutive interior angles have to be?
That's what it says on congruent.
Supplementary? Is that what you said?
Yes.
Oh, sorry. I thought you said complementary. Yep, supplementary. Good. So we're going to go through each of these and decide if they are one of these properties. Okay? So number 3, what relationship do these two angles have? Corresponding. What do these arcs mean for corresponding? You don't have to write this, no. We're just talking about it. So it says corresponding and they're congruent. Is that one of the properties that prove that lines are parallel? Yes. So is this enough information to prove that M is parallel to N? Yes, it is. Okay, so you would say yes because corresponding angles are congruent. It says state the theorem. So instead of you memorizing the names of the theorems, this is what you're putting in the place. Okay? Corresponding angles are congruent. You're putting the property instead of writing out the name of the theorem. Because the name of this theorem is corresponding angles, congruence, theorem, converse. That's a lot of words, yes? So instead of writing that, you're going to write corresponding angles are congruent. Okay? Number 4, what relationship do these two angles have? They're vertical. Are they on this list? No. So is this enough information? No. Here's also what kind of can give you a hint. What two lines are we trying to prove are parallel? M and N. Is there any information on line N? No. Okay, so that is especially why there's not enough information. Number 5, what relationship do these two angles have? They're still vertical. Okay, is vertical on this list? No, so they're not enough information. And then number 6, we have these two angles marked congruent. What relationship do they have? Alternate exterior. And they're marked congruent. So are alternate exterior angles congruent? Yes. Is that enough to prove the lines are parallel? Yes. So you'd say yes because alternate exterior angles are congruent. Okay? This is not what you're writing on the back of the paper. I'm very sorry. Do you want a new one? All right, so you're going to write linear functions. This should be a familiar word to you. This is the part that's from algebra. This is all like review. Not new information, just review. So what is the root word of linear functions? Line. So whenever you have a linear function, you'll have an x and y axis. And then you'll have a line. The line could look like this, could look like this, could look like this, could look like this, could look like many things, okay? But it will be a completely straight line, all right? The number one thing about it to know is the slope-intercept form. Please make sure you write in this before you write y equals mx plus b, because you need to know why we call it the way we call it. So slope-intercept form is y equals mx plus b. If you're planning on taking the PERT at the end of the year, this is on it. It's like the only thing I remember from when I took it. So, the slope-intercept form has two things in it. Can anybody take a stab at what two things are in the slope-intercept form? The slope and the intercept. It's actually going to be the y-intercept to be in particular. Okay, so that's why we call it the slope-intercept form. Which of these letters, y equals mx plus b, which of these letters represent the slope? M. So go ahead and write that. M represents the slope. And then the slope is always written as a fraction. And it's something over something. It starts with an R, both of them. Does anybody remember what it is? The rise over the run. Good. So I'd write that in too if you don't remember that. Rise over run. When you rise, which direction are you going? Up or down. And then when you run, you're going left or right. Okay, so we'll talk about it. So rise over run. I always say in order to get up in the morning, you have to sit up. That's up first, and then before you can go anywhere else. Okay, so rise first, run second. There are 4 different types of slopes. Where do we see slopes most often? The word slope. Okay, in a mountain. You ever been skiing? Have any of you been skiing? Are you a good skier?
I'm the average skier.
Average skier? Okay, I respect that. My family, they're all skiers. My dad's from New York, so they ski a lot. I've been to Colorado, Maine, New Hampshire, all the things that are up there. I am not a great skier. So you're an average skier, I commend you, because skiing is very difficult. There are 4 different types of slopes. There's a flat slope. This doesn't have any slope at all. It is called the bunny slope. So can you guess who is on a bunny slope?
Beginners.
Beginners, children, me, yes. No, not really. There's literally no slope. It's like as flat as the ground right now. They're mostly for people who are learning how to put on their skis or their snowboards, You ever seen a beginning snowboarder? It's really funny. They look like a flopping fish. They can't get up off the ground. Super funny. So there's the bunny slope. Then there's I think it's a green square. I don't remember the shape, but it's green. So it is wide. It's got a slight slope. There are no jumps. This is where, if you're an average skier, this is your mainstay. Okay. And there's a yellow one. It is not as wide. It's got more steep. Sometimes there are jumps. So if you are feeling adventurous for the day, you go there. And then there's the hardest slope. Does anybody know what it's called? It's called the Black Diamond. There is also a double Black Diamond. I don't even want to know what that consists of because I've been down a Black Diamond, not by choice. So what I want you to envision for a Black Diamond, okay? So instead of, if you're going down a hill, okay, if you're going down the hill, you can see the incline, right? So envision yourself in skis going downhill, right? So normally, land looks like this, right? Like if you were skiing, going towards the picture, okay? Envision you're going that way. Do we all envision? Okay. A Black Diamond, at least the one in Colorado, the land sloped like this. So the sides went down instead of being flat. Does that make sense? So it's thinner, and there's more of an incline on the sides. What do you think is on the sides of the slope? You're in the mountains. Trees, right? Okay, trees. So you have to be a very good skier to do a Black Diamond. There are jumps. It's icier, and there's not very much space. Not at all. So if you know anything about skiing, you have two skis, right? Does anybody know what this is called to go the speed you want to go? You know what it's called? It's a food. It's French fry. So you do French fry or you do pizza. Okay? Pizza, you go slow. French fry, you go fast, right? So guess where I stay? Pizza, right? So the problem with pizza is that if your skis cross, what do you think is going to happen? You're going to fall, you're going to roll, or you're going to lose a ski, or you're going to get hit places you don't get hit. It's not fun. So I don't like to ski. I have an older sister who's the same like me. She's very much not athletic, so she shouldn't be doing these activities anyways. But, so there's her. And then I have a younger sister who's the most amazing skier. Not the most, but she's a good skier. She's younger than me, okay? So there was this one time I was 10, and my dad took my younger sister, because they're both good at skiing, and they were going to do a yellow slope. That's the middle slope, right? My sister and I were going to go do the green slope, okay? So we go up the ski lift, we get on the green slope, and then at some point the green slope and the Black Diamond cross. So I end up on a Black Diamond. I am 10 years old. I am terrified. So what do 10-year-olds do when they're terrified?
Cry.
They cry. I'm sobbing, right? Because I just think that this is how it ends. This is how it all ends for me. I'm going to run off. I'm going to hit a tree. I hit a jump at one point. I did hit a tree, not at full speed. So what I decided to do is sit on my butt and cry and just scoot down the mountain. That is what I did, okay? And meanwhile, you would think, there are other people on these slopes, right? If you saw a 10-year-old sobbing, you would, stop and help them, right?
Yeah.
This is like a TV show, what would you do? None of these people. They're all like this is me. They're like, hey, honey, you good? All right. That's tough. It was terrible. My sister left me. We're not very close people. We're not my favorite. So anyways, when we talk about each of these slopes, I'm going to refer you to a slope that you would be on in skiing. I highly suggest tubing. It's much safer. You don't bruise. You don't like tubing? Not water tubing.
Oh.
I'm talking snow tubing. Yeah.
Oh.
I don't like water tubing either. Water tubing is great if you have good eyesight, but if you have glasses, you either don't wear your glasses, so you're blind, so you can't lean into the turns, or you wear contacts and you get water in your contacts, or you wear goggles and look like a nerd. Those are your options. Am I right? Do you go tubing? Or you go blind. But then I can't see. So then I like to see what's going to happen. You know what I mean? So anyway, I have really bad eyesight. Everything's blue out there, bud. I don't even know. So anyways, if you ever have the chance, go tubing. Or maybe try snowboarding. I've heard that's fun. But anyways, we'll talk. So there are 4 types of slopes. Go ahead and draw this picture. It's like a little mountain, and then a plateau, and then a drop off. It didn't have to be perfect. So when we read from the left to the right, correct? So that's how we look at graphs. So this first one, from the left to the right, is getting taller or smaller? Taller. So this would be called a positive slope. Nobody skis up a mountain. You take a ski lift, but just pretend. So you're going to write the word positive on the side that's going up. And then the side that's going down, you're going to write negative. I've had a lot of people ask if the next one is neutral. That's not a thing, so don't ask me. So negative, if you're going left to right, it's going down. This is probably like a green or a yellow. Nice little incline. Not too bad. The next one it's a horizontal line. See my bunny? That's a bunny slope. This is 0 slope. So I want you to write 0 and horizontal. What letter am I emphasizing? The Z's. That's a way to remember it. So if there's 0 slope, it's a horizontal line. 0 horizontal. All right, and then this is what it appears to me as a black diamond. That's me falling to my death. Just kidding. Not really. Maybe that's what a double black diamond looks like. This is called undefined. When I first started teaching, I had this picture of me from like 2000 skiing. And I actually was in, you've seen like the Acme barriers? Like the orange barriers that keep you from going places. This was like the orange like webbing fencing, you know what I'm talking about? Yeah. I crashed into it. So there was a picture of me under it, smiling for the camera. Anyways, I normally show that, but I can't find it. But anyways. So, those are slopes. We're going to go back to the slope-intercept form really quick and talk about the other piece. We talked about slopes. Now we need to talk about intercepts. B is the y-intercept. So go ahead and write that in. B is the y-intercept. All right, so the y-intercept is where the line, so if you look at my green lines, these are 3 examples. It's where the line crosses the y-axis. Okay, so it's where it crosses the y-axis. Everyone see? Put a nice big old purple dot. Okay, so we're going to use this information. You're going to have numbers instead of letters. This is what a slope-intercept form would look like. And I would ask you what the slope is. So what is this slope if I have y equals 1/2 x plus 3? Is 1/2. You don't have to write this part down. We're just talking. And then what would the y-intercept be? 3. So if it's in slope-intercept form, it's very easy to see. If it is not, you're going to have to make it look in slope-intercept form. So go ahead and write both of these down. So we got 3x plus 4y equals 12. And 2x minus 4 equals 6y. So when we're putting something in slope-intercept form, what letter are we getting by itself? Y. So y is immediately attached to 4. So we need to get 4y by itself first. So what is on the same side as 4y? 3x. So how do I move that to the other side? Subtract it. So before you continue with the math, can you subtract a letter from a number? No, so you're going to write them next to each other. If we want it to look like mx plus b, what needs to come first? 3x. The 3x, at negative 3x. And then, am I going to put a plus 12 or minus 12? Plus 12. All right, I have one last step to get y by itself. It's being multiplied by 4, so we need to divide each piece by 4. Reduce what we can. Does negative 3 over 4 reduce? No. So negative 3/4 x. And then does 12 over 3 reduce? Sorry, 12 over 4 reduce? Yes, 2. 3. So don't circle this. This is not what we're looking for. We put it in slope-intercept form to find the slope and then the y-intercept. So what is the slope now? Negative 3/4. And then what is the y-intercept? 3. No, you shouldn't put the x. So x and y represent all the points that are on this line. The next one, we got 2x minus 4 equals 6y. We want to get y by itself. We already have 6y by itself. So what is the 6 doing to the letter y? It's multiplying. So what is the opposite of multiplying by 6? Dividing by 6. Divide each piece by 6. Reduce if you can. Does 2 over 6 reduce? Yes, 2. 1/3. Minus, does 4 over 6 reduce? Yes, 2. 2/3. Oop, that's not 2. All right, so we don't really like the order this is written in. So what could I do to make it look like y equals mx plus b? Yeah, I just switch them. So I can put the y on the other side. So I just flipped them. So 1/3 stayed positive and 2/3 stayed negative. All I did was put the y on the other side. So knowing this, I'm going to find the slope and the y-intercept. What's my slope? 1/3, and then my y-intercept? Negative 2/3. All right, we got one more thing to talk about together before tomorrow. To find the slope between 2 points, you're going to use this formula. So go ahead and write it down. We do one example, then we flip to the front. So if you're running out of room, it's okay. We're going to do this, and then one more problem, and then flip to the front. So slope between 2 points. Remember, slope is rise over run. Here's what extremely matters. When we said we rise, what directions do we go? Up and down. Which axis is the up and down axis? The y-axis. And what letters on top with the rise? The y's. Okay, and then we said the run is on the bottom. It goes left and right. Which axis goes left and right? The x. That's why the x is on the bottom. So make sure y is on the top, x is on the bottom. That's the #1 mistake I see every year. And then also, if you notice, these two come from the same coordinate, and these two will also come from the same coordinate. Okay, so make sure those line up as well. We're going to do our first example. You just write down -6, 3, and 7, -4. We're going to use our formula, y1 minus y2 over x1 minus x2. If you notice, I write it like this so that I know my negatives are already here. It helps me plug in very easy. What is my first y going to be? 3. All right, and then what is my, it's not our bell, what is our second y going to be? -4. When I plug in that -4 and there's already a negative, what's going to happen? Turns into a positive. Good. Then I have my first x, which is -6. And then my second x, which is What did we say? 7. All right, now we just do math. 3 plus 4 is? 7. And then minus 6 minus 7 is? Negative 13. Is it negative, or sorry, I'll say this way. Is 7 over negative 13 the same thing as negative 7 over 13? They are all the same. Doesn't matter where the negative is. If it's out front, if it's in the top, if it's in the bottom, it's the same. Think about this. If you have negative 1 over 2, what is that as a decimal? Negative 0.5. If you have 1 over negative 2, what is that as a decimal? Negative 0.5. If you have negative 1/2, what is that as a decimal? Negative 0.5. So the negative does not matter where it is. Top, bottom, off to the side, same thing. Okay? You're going to flip to the front at this point. So we're all going to do number 1 together. I'll show you the math way to do it and then the graphing way to do it. What's wrong? Oh, no.
I'll fix it later.
I'm so sorry. She did it on the other notes. That's sad. Okay, so we're going to name... I'm going to name this point. I just highlighted it. We'll name this x1, y1, because it's on the left. And I'll name this one x2, y2. Does it matter which one I label x1, y1, x2, y2? No, I just need to decide. Okay, I just want us all to be on the same page. I just think it's easier to look from left to right. That's just me. All right, so now that we have that labeled, what is my y1 going to be? 1, yep, is right here. All right, and then what is my y2 going to be? Negative 4. When I plug that in, that will become positive. My x1, so my first x will be negative 2. And then my second x, 1. All right, so from here we do 1 plus 4, which is 5. Minus 2 minus 1, which is negative 3. And that's your slope. You can also count. Some people are really not good at counting. So if you want to do this way, that's fine. If you want to do the counting way, it's fine. Look at this slope. Remember that it's rise over run. Is this slope positive or negative as it's going from left to right? It's negative because it's going down, so it'll be negative. You're trying to get from this point to this point. How many do we have to go down? 2, 3, 5. And then we have to go over 3. So did we get the same answer? Yes, you should get the same answer. Remember, the negative doesn't matter where we put it. Out, off the side, in the bottom, in the top, same thing. Number 2 is a vertical line. So what did we say the slope was for a vertical line? It's undefined. So that's the slope. The next one, we got 3. Is this a positive or negative slope?
Positive.
It's a positive slope. So how many do we have to go up? 3. Was it you that said you weren't good at counting? It's okay. And then we go over how many? 2. So 3 over 2. You leave it like that. You don't make it a mixed number. You're going to do the next 3 by yourself. You can use the counting method or the graph or the formula, either way.
Miss Marshall.
Yes, ma'am. first one, is it positive or negative? Negative. How many do you have to go down? 4. And then over? I agree. This next one, I see a lot of wrong answers. Did you check your notes? It is a 0 slope. So remember, horizontal is 0. So you can literally write the number 0. That's it. All right, and then the last, positive or negative? Negative. So we go down how many? 2. And then over? 6. All right, and then do we reduce in math? Yes. We do. So what does this reduce to? Negative 1/3. All right, so here's what that means. That means you could technically go down 1 and over 1, 2, 3, and you'd still land on the line. 1, down 1, over 1, 2, 3. That makes sense. So if you can reduce, that means there was a shortcut. You can go ahead and put this away.